Welcome back to Chem Talks. Today, guys, we are going to start filling our toolbox. I don't know if you know this or not, but when you signed up for chemistry, you were given a toolbox. Okay? And it's these tools that we use to build chemistry with. So far, we only have a few tools in there. We got a hammer, a saw, right? We've learned to use our calculators. We have learned how to do rounding, hopefully by now. We've also learned how to use lab equipment. Today, we're going to continue building on this. Please don't tell my son I stole his toolbox. Okay, we're going to add some more to this. If I look at my real toolbox, this is my favorite tool that I have. I've had this since I was probably 6, 7, 8. It used to be my grandfather's. When I was a little kid, I spent a lot of time with him in his workshop, and this was my favorite tool to use. He would set me up, I'd saw stuff out, I'd start sawing, the blade would break. With his patience, he'd put a new one on, I'd saw some more, and I'd break another blade. And, you know, to saw a little star or something like that, it'd take me 4 or 5 blades. Okay. Luckily, he was a very patient man. But as I practiced, as I got more experience using this, I was able to cut things out without breaking the saw blade. And that's what we want you to be able to do. Do a lot of practice so that you will not break your saw blade, so to speak. Today, we're going to start talking about dimensional analysis. This is probably the most important tool that you will have in your toolbox this semester, because 50 to 70% of the problems that we do in our chemistry class are going to use dimensional analysis to find the answer. So if you don't know the answer, or you don't know how to do dimensional analysis, you're going to be lost in getting the answer. So it's very, very important that you do this, that you learn how to do dimensional analysis. Most of you have probably already done this before. You just know under another name. We'll talk about that in just a minute. So let's go ahead, get started, and take a look and see what dimensional analysis is. Okay, dimensional analysis, often referred to not as only dimensional analysis, but factor labeling, because we're dealing with the labeling of numbers. At least we are here in chemistry. Remember, every number, every unit needs a unit, okay? No naked number. So we got to make sure we do this. Do the dimensional analysis so we can get the correct units on. The other name that you guys have probably heard this under is ping pong. Now, I know I just lost about half of you. Half of you are sticking your fingers in your ear like it's going, la, 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 la. I don't want to hear about it. Yes, you had dimensional analysis as a freshman. Maybe you struggled with it, but now you're older. You guys got more experience. You're going to do a lot better in this. So please hang with me. What is dimensional analysis? Well, all dimensional analysis is simply a tool for problem solving. Okay, it's a way to solve problems. Okay, it allows you to convert between units, and that's what we're going to be doing here in chemistry. For example, we can convert from meters to feet. We can go from meters to kilometers. We can go from feet to inches. We could go from grams to moles. We can go from number of moles to number of particles. There's a lot of different applications for this. But like I said, probably 57% of problems that we do are going to be dimensional analysis. So it's really important that you get this. So let's talk about the underlying principle behind this. And what that is that any number or any expression can be multiplied by 1 without changing its value. And that's what we're going to be doing, is we're going to be finding a way to multiply by 1. For example, 6 times 1 is 1, 10,000 times 1 is 1, 1,000,000 times 1 is 1. It's still the same thing. The only thing that we're going to be changing is our units, really, or when we get later on at the end of this year, we're going to be changing chemicals using stoichiometry. Okay? To do this dimensional analysis, we use what's called conversion factors or unit factors. And all these are the factors that equal 1, that allow us to convert from one unit to another. Okay, and that's the whole key behind this. Okay, conversion factors may be made of any two terms that describe the same or equal amounts of what we are interested in. Let's go back and take a look at some basic units to measure. Let's start with the English measure. 1 unit, okay? 1 inch is equal to 2.54 centimeters, okay? So about that much. Now, it doesn't matter if we say this is an inch or 2.54, it's the same value. It's the same length. It doesn't change just because we call it something different, okay? Let's take an example here. My Nalgene. I love my Nalgenes, okay? A Nalgene bottle contains 1 liter of liquid, okay? Or, if we look at it, it's 1,000 milliliters. Okay, no matter if we call it 1 liter or 1,000 milliliters, it's going to be the same amount, Okay, it doesn't matter what we call it, it's still the same amount. We could also look on here and say, oh, it's about 34 ounces. So we could say it's 1 liter, 1,000 milliliters, about 34 ounces. Okay, it doesn't really matter. It's the same amount. We just put different units on it. So to do this, we have to come up with what we call conversion factors. Okay, and conversion factors are simply a ratio. That's the easiest way of thinking, or a fraction. So if we look at the example we did comparing inches to centimeter, what we can say is that 1 inch is equal to 2.454 centimeters, or we can say 2.54 centimeters over 1 inch. Okay, it doesn't really matter which unit goes on top. Okay, because what's going to happen is they cancel out and become 1. Okay, 1 inch is equal to 2.54 centimeters. So it doesn't really matter what goes on top or bottom. How do we make that decision? Well, it's based on what answer we're looking for. Okay, and we'll explain that here in the next couple steps. So the steps to dimensional analysis, basically 5 steps that we want to do. The first thing is we start with what we're given in a problem. Let's say it says convert 5 meters into feet. Well, we're given 5 meters, so that's what we're going to start with. Second thing is then we look at what we are solving for. In this case, we want to convert meters to feet, so our feet's going to be what we're looking for. Okay. Then we have to use the conversion factors to go from our known value of meters into our unknown of feet. Okay, and it's kind of like following a road map. Okay, we follow different turns, going left and right. Well, we use different conversion factors to get us to our final answer. And as we go along, we're canceling out the units to make sure that we end up in the correct place, that we did not make any wrong turns. Okay, and then final thing in this is to do the math. Okay, multiply everything through, write your numerical value, and also don't forget to put the new units, no naked numbers. Okay, take a moment, pause this video, copy these down. These are going to be very important. Star them, circle them, put fluffy bunnies by them, whatever you want to do, but these are very important. So pause it and come back and see me once you're done. All right, you got those written down. Now let's talk about how we solve problems doing this. The first step is what we have to do is use a conversion table, also known as a ping pong table, okay? Or some people also will call it railroad tracks, depending on where you learn it. So if you're looking at a net, you may hear railroad tracks. It looks something like this. And as I said, our first step is always start with our known. So we put our known value in the first block. Second block then is going to be our conversion factor. And if we need more than one conversion, we'll add more blocks to it. Okay, so that's our first thing we do. Second thing after we have it all set up is we do the math. So there's what our conversion table looks like. This is our answer. So how do we do the math? Well, if you're going across your ping pong table, you're going to multiply. So as you go across, you multiply the numbers on the top, left to right. Same thing on the bottom. Now once you get those done, anything on top gets divided by anything on the bottom. Okay, think of it as a fraction. You're doing dividing that way. So there's a bunch of different ways you can do this. You can multiply all the top, multiply all the bottom, and then divide, or you can do it one step at a time. The order of operation isn't really important as long as you do it correctly. You're multiplying when you need to multiply and divide when you're dividing. So let's take a look at a couple examples. Our first one here says convert 5 inches into centimeters. Okay, well, what do I know? I know I have 5 inches. And I know by looking at my conversion table, my cheat sheet, which you guys aren't going to have to memorize, that 1 inch is equal to 2.54 centimeters. Okay, so I know that. So I can go directly from inches to centimeters. Pretty easy. So let's set up our ping pong table. Actually, before that, this is what we know. Okay, so the question is, which one of these are we going to want to use? Which one of these conversion factors? The 1 inch or the 2.5 over 2.54 centimeters, or 2.54 centimeters over 1 inch? Well, the question is, put what you want on top. We want to get centimeters, so that's going to go on top, okay, in this case, and inches goes on bottom. Okay, so what we're getting rid of on the bottom, we're getting rid of the inches, right, because we're converting from inches to centimeters. So in this case, we're going to use the second box. So let's go ahead and set up our ping pong table now. Start with what we know. We have 5 inches, and I want to convert to centimeters. Well, what I want is centimeters, so I'm going to put that conversion on top and inches on the bottom. So 2.54 centimeters over 1 inch. Now, here's where I do my canceling my unit. My inches cancel off, and all I'm left with is centimeters. Now do the math. 5 times 2.54 equals, then divide it by 1. And I get an answer of 12.70 centimeters. Remember, we're always going to two decimal places, so please carry those out. Okay, we can see inches canceled, left with centimeters. Let's go ahead and try another one. Okay, example 2. Convert 150 centimeters into meters. Okay, the only tricky part about this one is, remember, for metric, you have to know the prefixes. You're not going to be on a cheat sheet, so you have to remember what the conversion is. So what do we know? Well, I know that there's 100 centimeters in 1 meter. Okay, so I'm going to use that to set my conversion factor up. Let's go ahead and set our ping pong table, put our known in, that's 150 centimeters. Okay, now I want to go to meters, and I want to get rid of centimeters. So I'm going to put meters on top, so 1 meter over 100 centimeters. Okay, in this case, my centimeters cancel out. I'm left with meters, so I'm going to take 150 centimeters times 1 divided by 100 and end up with 1.5 meters. My units cancel out. I'm left with meters, which is what I am looking for. Pretty simple. Hard part is you got to remember those prefixes, metrics. So if you don't have memorized, go back and memorize them. Another one, same type thing, but we're using a bigger number. 1.2 liters going to microliters. Well, I know that in 1 liter there are 1 million microliters. This is from my memorized chart. So I set it up just like the previous one. 1.2 liters. Okay, I want to get rid of liters, so that's going to go on the bottom. 1 liter under 1 million microliters. 1.2 times 1 million equals, divided by 1. Okay, my liters cancel out. I'm left with micrometers, and 1,200,000 microliters is my answer. Pretty simple. Okay, let's try another one, a little harder here. 1.5 kilometers to centimeters. Well, if I think about my chart, kilometers is kind of on the positive side, the whole number side, and centimeters is on the decimal side. So there's no direct conversion right between kilometers and centimeters. So I'm going to have to go through the base unit first. So I need to think about this. I got to go from kilometers to my base unit would be meters, and meters to centimeters. So it looks something like this. This is going to be a 3-step process. Okay, so I'm going to have 3 spaces on my ping pong table. My known, then go into meters, then go into centimeters. So let's set this one up together. Okay, start with what I know, 1.5 kilometers. Well, what's my conversion between meters and kilometers? Well, I know that in 1 kilometer, there are 1,000 meters. Okay, so now my kilometers cancel off. I'm left with meters, but I still got to go to centimeters. Well, what do I know? Well, I know that in 1 meter, there are 100 centimeters. I want to get rid of meters, so it goes on the bottom. So my meters cancel off. I'm left with centimeters. How do I do the math? Take 1.5 times 1,000 times 100. It's going to be a big number, right? I come up with 150,000 centimeters. Pretty simple. We just added one more step because we had to make it one more conversion. All right. One more here for you. 6.2 miles going to meters. So we're taking from English units going to metric units. Now there's a couple different ways to do this. I'm going to show you one. It doesn't mean it's the only way. Now if you take a different route to this, you may get a slightly different answer because of inconsistencies in conversions between metric and English. But let's try this one. Well, if I look at my cheat sheet, I know that I have a conversion between miles and kilometers. And once I get to kilometers, I know, well, kilometers and meters, that's metric, pretty easy. So I'm going to do a 3-stepper on this. I'm going to go from miles to kilometers, kilometers to meters. So let's set our ping pong table up. Start with what I know. I know 6.2 miles. My conversion, if I look at my chart, is 1 kilometer is equal to 0.62 miles. So I set it up like that. Miles goes on the bottom because I want to cancel out. Okay. Now, how do I get to kilometers to meters? Well, I know that 1 kilometer is equal to 1,000 meters. The question is, which one goes on the bottom? Well, I'm trying to get meters, so that goes on top. Trying to get where to kilometers, so that one goes on the bottom. My units cancel. Okay, and I'm left with the units of meters. Now what I have to do is do the math. 6.2 times 1 times 1,000 divided by 0.62 divided by 1 gives me an answer of 10,000 meters. For those of you that are runners out there, right, we talk about running a 10K road race, 10,000 meters, 6.2 miles. Okay, so you can also put some of these, check your answer, make sure it sounds right. Use things that you know. Okay, I got one more that I want you guys to do. This is going to be your homework, okay? This is going to be a little practice. This is a fun one. What I want you to do, convert 1.5 years into minutes. Now, this is going to be definitely a multi-stepper, so write it out how you want to do it first, and then fill in, make sure all your units. So your given is 1.5 years. Your answer should be in minutes. All right, guys. Until I see you in class, try this problem. Take care.